All right, guys. Hey, welcome back. I told you, part two, it was coming. All right, so part two today, we're going to continue the factoring lesson. We're going to factor when the a term, right here, is greater than 1. Okay, it's a little bit different. We're still figuring out factors of a certain number that when I add them, I get the middle term. Okay, the differences, I should say. First, multiply the a and c term together. Okay, so a times c, that's 5 times 24, that gives me 120. Okay, so I want to find factors of 120 that when I add them up, I get 34. Okay, now some of you might see that rather quickly, but if not, let's just list some. We can do 60 and 20, 40 and 3, 30 and 4. Looking at those factors I listed, and there's a lot more, but I'm just stopping there. I can see that 30 and 4, if I add them up, I get 34. Okay? So here's what I'm going to do. I'm going to take this original quadratic, and I'm going to rewrite it to where it's still the same thing. It's just some extra terms with it. So the first term, I'm going to leave it as is. It doesn't matter the order here. I could pick 30 or 4 to start with. So we'll put plus 30x plus 4x plus 24 equals 0. Now looking from my first part of the video, you could see that I put x's here. I didn't do that before, but now I am. Okay, why am I doing that? We'll take a look. If I add these up, I get the original, right? So technically, these are the same thing. I didn't change anything yet. Your next step is to group. We're going to group the first two terms, and we're going to group the second two terms. Okay? I would always put a plus sign here. Even if there's a negative number here, still put a plus sign. Okay? That way you're not confused in terms of distributing a negative. What do I do next? Well, I am going to factor out a GCF. And we did that in the first part of the video. For this guy, I could factor a 5x out. Now remember, when we factor, it's like you're dividing it. So 5x divided by this just gives me an x left, plus 6 for that guy. Now, on the other side, I'm going to factor a GCF here. So I could factor a 4 out of both terms. So I get an x plus 6 again. Okay? So we want to put a step, factor, GCF. See how that came up to be the same? Curious, isn't it? Why do I want to do that? Well, here's the deal. You want these two binomials to be identical, because what we're going to do is we're going to technically factor that binomial out, because they have it, right? Both terms have this. So I'm going to factor out an x plus 6. And when I do that, what I'm left with is a 5x and a 4. And that's going to equal 0. So literally, I'm taking this expression. If I multiply it by 5x, I get this. Take this whole expression, multiply it by 4, I get this guy. So like I said, you're factoring out this guy. When you solve these problems for homework or for future practice, that's the goal. You have to make sure these match up, or I can't really factor that binomial out. Using the zero product property, we'll set each one equal to 0, just like that. For the first step, we get x to be negative 6. On the other side, we get 5x equals negative 4. And if we divide, we get x to be negative 4/5. Those are my two answers for that guy. This is different. It's not our normal way to break this up, okay? But I want you to think about this for a second. If I multiply these two together, I'm going to get the original, okay? Because both of these are factors of what? If we take a look, they're both some sort of factor. They have some relationship, I should say, with 5 and 24. That's why it really doesn't matter which one's first. I could put 4x over here and 30 over here and still get the same result, okay? What some people have done in the past, they'll guess. What are factors of 5? 1 and 5. What are factors of 24? 6 and 4. They'll multiply this out to see if you get the original. If you do, then there's my two factors. You can do that. Guessing and checking takes more time unless you're really lucky. Okay, so I don't know. I'm leaving it up to you, to be honest with you. This way is a little bit more foolproof because you're going through a process, and this way you can actually see what happens. If none of these factors worked, that just means this can't be solved by factoring. It still has an answer, but it just can't be factored nicely. Okay, let's try one more example. Okay, here we go. Same process. Because this is bigger than 1, I'm going to multiply both of these. I get negative 24. That's my AC value. And I'm going to find factors of negative 24 that give me negative 5. Let's just start listing it. 6 and negative 4 would work. Negative 12 and 2. Negative 8 and 3. There are more, but I'm just stopping there because I have my answer. And it is this guy right here. Negative 8 and 3. If I add them up, I get negative 5. Okay? And if I multiply them, I get negative 24. Bring down these two. We're not going to change them. We're essentially rewriting this quadratic with some more terms. Okay? So it's like a step before simplifying. We have 6x squared minus 8x plus a 3x minus 4 equals 0. So once again, these two terms, if I combine them, I get the original. All right, so technically I didn't change nothing yet. Next step, group them. We'll group the first two terms, and then we'll group the last two terms. Always, if a plus sign's not here, put a plus sign there. Okay. Factor a GCF out of both of these. So for the first one, I could factor a 2x out. So I'm left with 3x minus 4. Now you can probably see already, wait a minute, Mr. McCullough, I want this to be the same, and it already is. So what can I factor out of here? Well, you can factor 1, right? They both share a common factor of 1. So that's fine, okay? Because like I said, ahead of time, you're going to see that, oh, this is already the same. Factor 1. Now, we're going to factor out that binomial. So that's going to be 3x minus 4. And then what's left is what's on the outside of those guys right there. Now, could you have guessed this? Yeah. Factors of 6, 3 and 2. Factors of negative 4, negative 4, 1. Multiply them out. If we get the original, those are factors. So I'm not trying to downplay guessing and checking, but it is very helpful. I mean, down the road, are you going to remember everything here? Depends. It really does. Set each one equal to 0. Remember, that's the zero product property. Over here, we get 3x equals 4. If I divide by 3, I get x to be 4/3. There is my first solution, which is what, 1.3333333333. All right, just goes on forever. The other one, we have 2x equals negative 1, and then we divide by 2, you get negative 1/2. Those are your two solutions. That's where your parabola crosses the x-axis, right? Okay. That's it. So that's factoring when the a value is bigger than 1. If it's not, go back to the original process, just find factors of the c value that give me the b term, the middle value, okay? And then you don't have to worry about factor by grouping or anything like that we kind of did here, okay? Questions, thoughts, concerns, dilemmas? No? You guys are awesome. One final thing we're going to talk about, okay? And there we go. Instead of erasing, I'm just going to overdo it. I'm just going to pretend it didn't exist. Okay, the last part would be finding an equation by its roots. The word roots means solutions, means x-intercepts. Okay, so I'm going to give you the answers to my quadratic can you come up with the original equation? Think about this for a second. If I go back, which this is perfect. See, I'm so glad I didn't erase this. If I go back to this guy right here, notice that these guys are factors, right? And when I solve it, I get these answers. Can I take these answers and work my way backwards to get to the factors? I think I can. If my answer is -6, the equation that gets me that is this guy, x plus 6, right? Equals 0, which is factor. Over here, if x is equal to -4/5, multiply both sides by 5, add 4, boom, I get this guy. See how you're kind of working backwards? If I multiply these two, I get the original. That's pretty darn cool. So even though I have no idea what the original equation is, but I know the answers, I can get to that. Just working backwards. So its factors can give you that answer. Okay? Let's try it out. I got 2 examples for us to work through. First up, so my 2 answers are 1/2, and what was the other one? -5. So I have a quadratic. Those are the answers to it. Let's come up with the original equation. So what I'm going to do, if I look at this first one, if I do x minus 1/2 equals 0, in fact, let me just write that down. X minus 1/2 equals 0. If I solve this, that gives me that answer. And over here, x plus 5 equals 0. If I solve it, I get this guy. So then, I could say that those guys are my factors. Okay? We never really worked from here forward. We always came from here to get our answers. Distribute, multiply everything out. We have x squared plus 5x minus 1/2x minus 5/2 equals 0. Once we're done with that, combine terms. We can combine these x's together. X squared plus, that'd be what, 9/2 x minus 5/2 equals 0. There's my quadratic. If you graph this, here's where it's going to cross the x-axis at these 2 points. How cool is that? That's awesome. Very helpful, to be honest with you. Think of it this way. Let's say you want these 2 answers to work for your equation, but you don't know what the equation can be. There you go. You can figure it out from there. One thing I want to add to this. Let's say you don't want to have fractions for these coefficients, okay? Or you don't want fractions for these values. You could multiply everything by the denominator here. So for instance, if I multiply everything by 2, I get 2x squared plus 9x minus 5 equals 0. So if you want whole numbers, you can always do that, okay? Both of these, it's the same graph, okay? They're going to give you the same answers. I don't want you to think it's like, oh, I just did that because it looks nicer. No. Looks aren't everything, okay? It needs to also have substance. You can't just say, oh, it looks pretty. You got to have something else, right? Okay. What do you think? Pretty cool? I think so. I think it's pretty cool. All right. Let's do the final example. I hope you're having a good day today. I hope you're enjoying yourself. I really hope so. Okay, here are my solutions. Let's come up with the original quadratic. So let's come up with an equation where that's the answer. So it'd be x plus 3/4 equals 0. Over here, it would be x minus 5 equals 0. We're just changing the signs. Therefore, these must be my factors to this quadratic. Next step, just like we did in the previous example, distribute to fully factor, or not fully factor, but to fully expand this. We have x squared minus 5x plus 3/4 x minus, was it 15/4? Equals 0. Okay, next, we want to combine some terms. We're going to combine these guys together. We get x squared, would that be minus 17 fourths x minus 15 fourths equals 0. We're going to combine those fractions. And here it is. This quadratic will give you these two answers. If you want to get rid of the fractions, multiply everything by 4, because that's what the denominators are here. We get 4x squared minus 17x minus 15 equals 0. So this can also yield that same result. You just don't have the fractions to worry about there. And I highly encourage you, graph them both. Don't just take my word for it. Actually do that and see that it works. Okay, that's it. That's part 2 of factoring. Are there more? Yeah. We'll come back to when we talk about cubics and different methods for factoring cubic and different things like that. But for right now, this is the fundamentals. This is the basics. So hope you're doing well. I want you guys to have a great day, and I'll see you all in the next lesson.